right, so today we are reviewing Chapter 2. We are taking a test. This is the review that's for the test over sections 2.3, 2.4, and 2.7. However, there will be a couple review problems in there from sections 2.1, 2.2, 5, or 6. So this is one of the review problems. You're to graph the function g of x and its parent, and then describe the transformations. So this is the function g of x. It's a linear equation. We know that because x is to the first power. The slope is a positive 2/3, which means it should be going up and to the right. It's going to be going up 2 spaces to the right, 3. And your y-intercept is going to be the point 0, -4. So to graph the line, start by graphing the point 0, -4, then going up 2 over 3, and then up 2 over 3 if you want to make another point to make this as a nice line. So that's your function g of x. The parent linear function is the equation y equals x, where that goes through the point 0, 0, 1, 1, 2, 2. All of your x and y coordinates are equal, if you think about it that way. So that's the parent. And then as far as the transformations, the 2/3 in front, you would describe that as a vertical shrink by a factor of 2/3 because it's between 0 and 1. And then the -4 at the end is a vertical translation 4 units down. All right, moving on to the section 2.2, number 2. Write a function whose graph represents the indicated transformation of the graph of f. So this function f is the starting function. You're going to take that function and you're going to shrink it horizontally by a factor of 1/2. So the horizontal shrinks and the horizontal stretches are a little bit tricky because you do have to replace the x. So you have to think this x here is going to be replaced, but what's it going to be replaced with? It's going to be replaced with 2x because we have to take the reciprocal of the 1/2. So anything that's on the inside with the x, we have to think reciprocal or opposite if it's going right or left. So that x then gets replaced with this 2x. Since there was already a 2 in there, the 2 and that 2x together multiplied gives you 4x. And then you're also performing a vertical translation 7 units down, which basically means that the 7 needs to be subtracted at the end. So you've already got a positive 4 in the function, so just subtract 7 at the end of it, and now we have a -3 at the end. So g of x should equal the absolute value of 4x minus 3 after it. But the 4x would be in the absolute value sign, where the -3 is after the absolute value sign. All right, moving on, number 3. So in number 3, this is one of the new lessons. However, everything from section 3 is review of things that you did in Algebra 1 or Integrated 1. So in this problem, you're given a graph. Now, on your test, I don't think we're going to be given this information. But so if you were not given that information and you were just given 2 points, you would have to find the slope between those 2 points. So I didn't do that on here, but I think I will down here. So if I have a point at 0, 0, and I have another point at 212, I can label this as x1, y1, x2, y2, and my slope formula y2 minus y1 over x2 minus x1 would give me 12, which is my y2, minus 0, which is my y1, over 200, which is my x2, minus 0, which is my x1. So that would give me basically 12 over 200. So when you subtract, when your y-intercept is 0, 0, and you're subtracting that, and you're using that as one of your points to find your slope, that point really doesn't make any difference. So it ends up being the 12 over 20, or 12 over 200, which reduces to 3 over 50, or when you divide that, you get 0.06, which I decided actually probably does make more sense to change it to a decimal. So I kind of like this answer better and this description better than I do the first one. So this description kind of went with this slope, where this description went with this slope. Okay, so what do we do next? So once we've gotten the slope, you can just look at the graph. This one's a pretty easy y-intercept to find because it's at 0. So if your y-intercept is 0 and your slope is 3/50 or 0.06, which I like better, if you use y equals mx plus b and you're adding 0 at the end, it's not going to change the equation. So your equation will just be y equals 0.06x. As far as describing what's happening with that slope and what that slope represents, you have to kind of look at the graph and see what's happening. So what's happening here is the sales tax is increasing when the cost of the room increases. Well, how much is it increasing? The sales tax increases basically 6 cents or $0.06 for each dollar the cost of the room increases. So when the cost of the room is increasing, the sales tax is increasing 6 cents per dollar that the cost of the room is increasing. Okay, so something to that effect. Good. All right, moving on now to our next problem. Example, problem 4. Again, you will probably not be given this on your test. So what you will need to do is find 2 points, and I believe they're going to be given to you, but this one is a pretty easy point. If you look at your intervals here, if this is 0 and this is 4, then that has to be 2. So each line is going up by 2, which means this point is on 10 at the y-intercept, or the y-axis. So this is going to be the point 0, 10. And I'm going to use that for my x1 and y1. And then this point here has an x coordinate of 8 and a y coordinate of 6. So I'm going to use that for my x2, y2 in finding my slope. And I will find my slope up here. So m equals, again, y2 minus y1 over x2 minus x1. You do need to know your formulas for the test. So your y2 is 6 minus your y1, which is 10, divided by x2, which is 8, minus x1, which is 0. So when I subtract, I get negative 4 divided by 8, and then if I reduce that, I get negative 1/2, which is exactly what I had there. So that gives me my slope. I could also change it to a decimal, since it's a nice terminating decimal, negative 0.5. And then my y-intercept is pretty easily found just by looking at the graph. So I can use that as my y-intercept. So y equals mx plus b, where m is your slope and b is your y-intercept. So you could write your equation like this, or you can write your equation like this. Again, I kind of like this description better. Because if you look at your graph and you're just trying to describe or interpret the slope in ounces is decreasing over time in days. So if we look at our slope, the slope is negative, which is taking care of the decreasing part. So you don't want to say it's decreasing by a negative number. The decreasing is already taking care of the negative. So the slope is decreasing 0.5 or 1/2 of an ounce per day is basically what's happening there. I also had put the slope is decreasing by 1 ounce every 2 days. I kind of don't like that explanation. I would rather just say the slope is increasing by 1/2 of an ounce every day. So I'm going to actually change that here by 1/2 ounce every day. Yeah, I like that better. Okay, so again, when you see something like this where you're given a graph, you're finding the slope and writing the equation and then interpreting the slope. All right, the next one from section 4 is an example of our 3x3 equations. So we've got 3 equations here, and we have to solve the system. So we need to find x, y, and z. So the first thing you look at are your coefficients for each variable and try to decide which one will be the easiest to eliminate. Well, I'm looking at these z's here, and I see a positive z and a negative z. So if I just take these 2 equations off to the side, the z's will cancel out right away because the positive and negative z added together is 0. So then we add our x values, our x terms together, we get 5x. The negative 3y plus 4y is a positive 1y, and then your 4 and negative 2 will equal a positive 2. So now this is what I call my equation 4, where these are my first 3 equations. So now you have to take equation 1 and use that one, since you haven't used it yet, along with either equation 2 or 3. Since you also want to, since you eliminated z here, you definitely want to eliminate z again. So you've got a positive 2z. We would like to get a negative 2z in either one of these equations so that we can cancel it out. Well, since the third equation already has a negative, it would make sense to multiply this third equation by 2 to make it a negative 2 here to cancel with the positive 2 there. So this is where I showed that work. The first equation, I just rewrote it, x minus 6y plus 2z equals 5. And then I took the third equation and I multiplied each of my terms by 2. So 3x times 2 is 6x, 4y times 2 is 8y, negative z times 2 is negative 2z, and negative 2 times 2 is negative 4. When you're doing these problems, please, please, please make sure you double check all your calculations and your signs. One mistake in the beginning is going to throw everything off, and it's going to be a time waster. So double check all your calculations. Okay, so now we have our equation 5. When we combine now our x's, our y's, our z's cancel, combine your constant, so we get 7x plus 2y equals 1. All right, so what am I going to do next? Well, the next thing I did, I noticed, okay, well, I'm looking at my equation 4 and my equation 5. And if I look at my x's and my y's, which one would be easier to eliminate? And I chose y. Since I've got a positive 2y here, if I can get a negative 2y there, then that will cancel out. But I need to multiply this whole equation by negative 2 in order to do that. So my equation 5 I just already had written down here. So I'm going to take negative 2 times my equation 4. So each of these terms get multiplied by negative 2. 5 times negative 2 would be negative 10x. 1 times negative 2 is negative 2y. 2 times negative 2 is negative 4. So then now my y's cancel out nicely. I combine my x's, I get negative 3x. Combine my constants, I get negative 3. Divide both sides by negative 3, and I get my solution for x is 1. So now you work your way back to, we have to find now y and z. So the hard part is pretty much done. We've got one of our variables. Now we have to plug it into either equation 4, or you could use equation 5. But I chose equation 4 since I had some room here on my piece of paper. So if you put 1 into the equation for x and then solve for y, 5 times 1 is 5, subtract 5, you get negative 3. So that gives you now 2 variables. Now that you have your x and your y, you can then use one of your original equations. So I used equation 1. If you see, I rewrote it over here. I substituted 1 for x, I substituted negative 3 for y, and then brought down the z and the constant, and then I'm going to simplify. So the negative 6 times the negative 3 is a positive 18. Combine like terms, I get 19. Subtract 19, which is negative 14. Divide by 2, which gives me negative 7. So then my answer as an ordered triple would be 1, negative 3, and negative 7. Those are my x, y, and z values. All right, number 6. Number 6. Okay, so it's the same type of problem. It looks the same, and again, you're going to look at the x's, the y's, and the z's and try to figure out, well, which one looks the easiest to eliminate, the x's, the y's, or the z's. So I noticed that I've got a 4y here and another 4y there. So since the numbers are the same, I only need to change the sign for one of those 2 equations. So I chose to change the sign of the third equation and combine it then with my first equation. So my first equation is x plus 4y minus 3z equals 1. My third equation, I multiplied by negative 1, which is going to change all my signs. So the 2x becomes negative 2x, the 4y becomes negative 4y, the negative 4z becomes a positive 4z, and the negative 12 becomes a positive 12 when I multiply all those by negative 1. Now my y's will cancel out. Add your x's together and I get a negative 1x. Combine your z's and you get a positive 1z. combine your 1 and 12, and you get 13. So now that's my equation 4. So now I'm going to hold off on that. Since I've used equation 1 and 3, I now have to use equation 2. So I rewrote equation 2 over here. And then again, I have to eliminate the y. I want to try to eliminate the y's. So I went ahead and used my first equation. Since I have a positive 12 here, I need to multiply this 4 by a negative 3 in order to get a negative 12 there. So my second equation, I wrote right here, and then negative 3 times each of these terms is what I wrote down here. So the negative 3 times x is negative 3x, negative 3 times 4y, negative 12y, negative 3 times a negative 3 is a positive 9z, and your negative 3 times 1 is negative 3. So then something strange happens. You end up, the x's, the y's, not only did we cancel out the y's, but the x's and the z's also cancel out. So if all of your variable terms cancel out, that basically gives you 0 on the left side. If you have 8 minus 3 on the right, you're going to have 5. So you have a statement that says 0 equals 5. Well, that is not a true statement. That is a false statement. So when that happens, where all your variables cancel out and you end up with two numbers that are not equal to each other, you would write no solutions for your answer. So these 3 lines, linear equations, would never cross, is basically the point. So there would be no solutions. Okay, so when you're doing these problems, also keep in mind that the way that the decisions that I've made in deciding what to cancel, you can choose to cancel something else, but you would still end up getting all of your variables canceling out at some point, and you would end up getting a situation that's similar. So even if you don't do the problem exactly the same way as I did, you will get no solutions at the end. All right, moving on now to the next page. Okay, so this is our story problem, where we have to write 3 equations, and then again we're going to solve for our 3 variables. But in this story problem, we've got bouquets of flowers, and we've got roses, we've got carnations, we've got tulips. So, and then the question is asking how much does each item cost. So I used my question to help me define my variables. Since we're trying to find out how much each of these things cost, I used R to represent the cost of 1 rose. I used C to represent the cost of 1 carnation, and I used T to represent the cost of 1 tulip. Then I'm going to use, let me back out a little bit so you can see everything. I'm going to use if you see each of these phrases I highlighted or circled in a different color. So 3 roses, 2 carnations, and 1 tulip cost $14. So that would be my equation 1. 3R plus 2C plus 1T equals 14. My second equation is what I have circled in red. So the 6 roses, 2 carnations, and 6 tulips that cost $38 would be the equation 6R plus 2C plus 6T equals 38. And then your last phrase here, you've got 1 rose, 12 carnations, and 1 tulip that cost $18. So that would be 1R plus 12C plus 1T equals 18. So those are the 3 equations that we are going to write from the given information. So now, just like the other 2, we're going to try to solve for R, C, and T, just like we solved for X, Y, and Z. And we want to first of all look at your variables here, or your coefficients, and ask yourself, well, which one would be the easiest to eliminate? Again, a lot of times I look for equations that have 2 terms with the same number but opposite signs. But if they don't have opposite signs, at least they have the same number. So I spotted that I had a 1T here and a 1T there. So I decided to eliminate the T's. So if I take my first equation and rewrite it over here, and then I take -1 times my third equation and I write it in here, up here, that the T's will cross out or cancel out. Then I would combine my r's. 3r minus 1r is going to be 2r. Combine your c's. 2c minus 12c is negative 10c. Combine your constants, which gives me 14 minus 18 is negative 4. So then that's going to be an equation that I'm going to use in a minute. But now I have to go back to my original 3. Since I used the first equation and the third equation already here to find equation 4, I have to use equation 2. And I have to eliminate the t again. So I could use the first equation or the third equation, but I chose to use the first equation. Since I'm trying to eliminate the t, and I have positive 6t here, I need to get a negative 6t here. So this negative 6 times all of these will give me a negative 6 there to cancel with the positive 6. All right, so I did that over here, this part that's in red. So I rewrote my second equation, 6r plus 2c plus 6t equals 38, and then I took the negative 6 times the first equation, which gives me negative 18r minus 12c minus 6c equals negative 84. Cross out your t's, combine your r's and your c's, and you get negative 12r minus 10c equals negative 46. So now that I have two equations with r and c in them, I can then use elimination to cancel out either the r or the c. So what I noticed here, if I look at my coefficients for r and I look at my coefficients for c, the coefficients for c are the same. They're both negative 10. So if I just multiply this equation 5 by negative 1 and change all those signs, then the negative 12r becomes positive 12, the negative 10c becomes positive 10c, and the negative 46 becomes positive 46. And then when I combine that with my equation 4, the c's then will cancel out. So now I can be down to, I'm down to one variable, and that's what you're trying to get. You're trying to get down to one variable so that you can actually solve. So when we add our r's, we get 12 or 14r. The negative 4 and 46 is 42. Divide by 14, which gives us 3. So now that we've got one of our solutions, we're going to put it back into equation 4 or 5. I chose to put it into equation 5 because I had room underneath. So this negative 12 is going to be multiplied by 3, since that's what my r equals. And then minus 10c equals negative 46. Order of operations, make sure you multiply the negative 36, bring down those other two terms, add 36, which gives you positive 10, then divide by negative 10, which gives me positive 1. So the carnation then is going to cost $1, the rose is going to cost $3, but we still need to find the cost of the tulips. So you can see it is going to end up being 3, but let's make sure you understand how. So once you've solved for two of your variables, you can then go back to one of the original 3 equations. So I chose equation 3, and you can see I wrote it in here, but I'm going to now substitute 3 for r, 1 for c, and then multiply first, which gives me 3 and 12, combine like terms, which gives me 15, plus t equals 18. If I subtract 15 from the 18, I get 3 again for the cost of the tulips. So the cost of the tulips is also $3 each. So that's an example of one of those story problems. And then in problem number 8, we have an example of a system of equations that ends up giving us infinite solutions. So we have 3 equations again. Look for variables that will cancel out. So if you look here, your y's, you have a positive y and a negative y. So I can add my first and second equations together, which is what I did here. So I rewrote my first equation, I rewrote my second equation, add your x's together. Don't forget, if there's no variable or no coefficient in front, those coefficients are 1. So if you add the x plus another x, you get 2x. If you add a negative 1z and a negative 1z together, you get a negative 2z, and then the 2 plus 2 gives you 4. Then I took my equations 2 and 3 over here and again eliminated the y's, so I didn't have to do any multiplying, which is really nice for this problem. Add your x's, you get 4x. Add your z's, you get negative 4z. Add your constants, you get 8. So now when you look at these two equations, you have to decide, okay, am I going to eliminate the x's or the z's? Well, it's going to happen, just so happen that everything is going to cancel. But in order to make that do that, in order to make this equation cancel with the other one, I'm going to multiply this equation by -2. Since I have a positive 4x here, and I've got a positive 2x there, if I multiply this equation by -2, that will give me the -4 that I need to cancel with that positive 4. So when I multiply all of these terms by -2, I get -4x, -2 times -2 is positive 4z, -2 times 4 is a -8. So everything basically cancels. Your 4x minus 4x is basically 0x. Your -4z and positive 4z is positive 0z. So basically these are just 0. And then the positive and -8 also cancel, which gives you 0. Since we do end up getting a true statement, so everything canceled out, 0 equals 0 is a true statement, that's when your answer, you would write down infinite solutions. Make sure you show all of your work, because all your work is worth points, not just the answer. All right, now we have a review problem from 2.5. Which was about, I think, your transformations. So this is a quadratic equation. We have a square there, which tells us it's quadratic. The 1/2 that's in front, so you're asked to describe the transformation, and this is your starting function, which is the parent quadratic. So the 1/2 in front is a vertical shrink by a factor of 1/2. The x plus 7 on the inside, again, things that are on the inside usually affect things horizontally, but it's going to be a translation. It's going to shift, and we always think opposite because it's x minus h. So the value of h would actually be -7. So even though it's a plus 7, we're going to the left 7 units. And then this -3 here is your vertical translation 3 units down. So there's 3 different statements that you need to write about the transformations. Okay, moving on to problem 10. Okay, so in problem 10, we now are jumping to section 7. So this is one of the newer sections. And you're given a parabola on a graph, and they're asking you to use the parabola to write the equation. And you're going to write the equation in vertex form. You're also going to write it in intercept form. You've got to know what your forms are. So if you're asked to write it in vertex form, it's the form that has the vertex in it. It's going to have the h and the k in it. So hopefully you have memorized these by using them enough. So y equals a, and then in parentheses x minus h squared plus k. I chose to use the vertex, which is the point 1,5 up here. And I chose to use the additional point for 1. So I'm going to substitute 1 for h, 5 for k, 4 for x, and 0 for y into this formula. So the x and the y are only being substituted temporarily. Your equation, when you write your final answer, your equation, it will have the x and the y in it. But the 1 and the 5 are permanent parts of your equation because those are the special x and y coordinates of your vertex. All right, so going back to what I was saying earlier, in place of y I put 0, a we don't know, that's what we need to find. X becomes 4, or h becomes 1. We still have this square here, don't forget that. And then your k you're going to replace with 5. Don't forget to follow your order of operations and subtract 4 minus 1, which gives you 3, then square the 3, which gives you 9, times a is 9a. Then I brought down the plus 5 and the 0, subtract 5, which gives me -5, and then divide by 9, which gives me an a value of -5/9, which kind of does make sense because the a value being negative means that the parabola should be opening down, which it does. So now I'm going to take that a value, -5/9, and I'm going to put it in place of that a here when I'm writing my equation. And then you still substitute your h with 1 and your k with 5. But the x and the y now are part of your equation. So that's vertex form. Okay, intercept form. So intercept form, the formula is y equals a, parentheses, x minus p, parentheses x minus q, where your p and your q are your x-intercepts. So if you look at your graph, you've got an x-intercept at -2 and another x-intercept at 4. So I'm going to put -2 in the place of p. Notice that I changed this to plus because I'm subtracting a negative. So when you subtract a negative, this becomes positive. And then my q, I'm going to put 4 in its place. Now, if you didn't already find a in the previous problem, you would have to substitute the x and y coordinate from an additional point to find a. But since we already found the a value in the other step, I'm just going to use that a value and plug it in. So my equation in intercept form then is y equals -5/9, parentheses x plus 2, and quantity x minus 4. All right, moving on now to number 11. So in number 11, you are given, told that it's a parabola that passes through the point 0, -5, and has a vertex at -1, 4. So you're going to use 0 for x, -5 for y, -1 for h, and 4 for k in your vertex form. Oh, I have it over here now. This is my final answer. All right, so in place of y, put -5. In place of a, we just put a because we don't know what that is yet. In place of x, you substitute 0 temporarily. And then again, I have a plus here because I'm subtracting a negative. So that becomes a +1. Don't forget your square because it's quadratic. And then your k, you substitute with your 4. Again, order of operations, if we add 0, what's in the parentheses first, I get 1. If I square it, I also get 1 times a is 1a. Then I bring down my other values, subtract 4, which gives me -9, then substitute that in for a. And when you're writing your answer, your a goes in front of your parentheses, x minus h, which if you're subtracting a negative, again, becomes +1. But the x and the y come back into your equation. Don't forget your square to make it quadratic, and then +4 at the end. So that's your equation in vertex form. Okay, the next problem that we have, number 12, is an equation that we're trying to write in intercept form. So it says write the equation of the parabola that has x-intercepts. So if it's telling you the x-intercepts, and that's the information that's given, then you're going to want to use intercept form, which is the equation or the formula y equals a quantity x minus p and then quantity x minus q. So you're going to substitute the x-intercepts. It doesn't matter which one you substitute where, but the 10 I substituted for p, the 6 I put in place of q. And then the point is 11, 8. So they gave us an additional point, 11, 8 for my x, which I'm going to temporarily substitute for x, and 8 I'm going to temporarily substitute for y. So I did all that substituting right here. So y is 8, a we don't know, x is 11, minus p which is 10, and then x which is 11, minus p which is 6. So this I did a little bit of calculations in my head. 1 minus 10, or 11 minus 10 is 1. 11 minus 6 is 5. If I multiply all that together, I get 5a. Divide that by 5, and I get a equals 8 over 5, or 8/5. So now now that I know what a is, I can substitute that 8/5 in my equation. And then the p was 10, the q was 6. So this is now my answer in intercept form. All right, the next problem here, we've got a baseball that's being thrown up in the air. The table shown, it shows the height y in feet of the baseball after x seconds. And they want us to first of all determine if the function is linear or quadratic. So if you look at the table, the x values are increasing consistently by 2, but your y values go up, stay the same, and then go down. Well, in order for a function to be linear, the y's should be increasing or decreasing at a constant rate. So and you're going to see that in the next problem, problem 14. Let me just show you that real quick. So if you look at your x values, again, they're increasing consistently, but your y values are also always increasing by 45. So if I add 45, I get 45. 45 plus 45 is 90. 90 plus 45 is 135. So your y values are increasing at a constant rate. So that's why this one is going to be linear, because the rate of change is constant, where in this problem the rate of change is not constant. So I said the rate of change is not constant, which I'm talking about the y values there. So that means it's going to be quadratic, because that's our only other choice. Now, when we get into other chapters, there are other options that we will choose from. But for right now, if it's not linear, then it's going to be quadratic. All right, so we have to write the function for this data. So if we know it's a quadratic equation, we're going to take 3 points, and we're going to use the standard form now instead of intercept, or instead of the intercept form or the vertex form of the quadratic. We're going to use the standard form, which is y equals ax squared plus bx plus c. Well, we don't know a, b, or c. The only information you're given are the points, and the points you can substitute for x and y. So we're going to do that with 3 points. So the y here I substituted with 6, x is 0 in both of these places, and then simplify. So 0 squared is 0 times a is just 0. 0 times b is 0 plus c equals 6. So over here, 0 plus c is just c, which is nice and convenient because now we know one of our solutions already. We know what c equals. So that's basically my equation 1. Then you write a second equation, again using your standard form. Substitute 2 for x, substitute 22 for y, and then simplify. Square that, you get 4a, multiply, you get 2b, and then now in place of c, you can actually put 6 in its place, because we already know that from the first step over here. And then what I did is I subtracted 6 to both sides so that I can get an equation now that has just the a and the b, 2 variables, and then equals the constant. So that's my equation 2. Then you're going to choose a third point. So you can choose this one or this one. It doesn't really matter. I chose this one, and again you're going to substitute the y value for y. So 6 is placing the y, and 6 is also going to be replacing the x. Simplify. 6 squared is 36 times a is 36a. 6 times b is 6b, and then replace the c with 6 also. Move that constant to the other side, and I get 0 equals 36a plus 6b. So now we have to look at these two equations and ask ourselves, all right, well, if I'm trying to solve for a or b, I need to eliminate either a or b. I chose to eliminate b because the numbers are smaller. So if I have a positive 6 in this equation, I would like to have a negative 6 in this equation. So if I multiply this equation by negative 3, then that will give me negative 6. So that's what I did up here. So I'm multiplying negative 3 times this second equation. And I'm also using the third equation. So let me show you that work over here. So when I took the negative 3 times my equation 2, I get negative 48 minus 12a minus 6b. And then my equation 3 was 0 equals 36a plus 6b. So the b's now cancel out. If I add my a values together, I get 24a. Add your constants, you get negative 24 or negative 48. Divide now by 24, and you get a is negative 2. So we found the second variable. The third variable, then the last variable that we have to find is b. So I'm going to take that negative 2 and substitute it back into this equation. It really doesn't matter whether you use the equation 2 or 3. I just chose equation 3. So I rewrote this equation 3, so this is still down here, part of the same problem. And I, oops, trying to move this up a little bit so you can see. All right, so 0 equals 36. In place of a, you put the negative 3 or negative 2 plus 6b. 36 times negative 2 then will be negative 72. Bring down your 0, bring down your 6b, add your 72, divide by 6, and you get b equals 12. So once you've solved for all three variables, now you're ready to finally write your equation in standard form. So one more time, I'm going to write my formula, y equals ax squared plus bx plus c. Substitute negative 2 now for a, substitute 12 now for b, and substitute 6 for c. So this is the equation for, or our answer for number 13. All right, so now moving on to 14. This one is going to be a little bit easier because it's a linear equation instead of a quadratic. So with a linear equation, you need to find the slope. So I just took the first 2 points here, took y2 minus y1 over x2 minus x1, and got a slope of 45. And then you could, now I went ahead and showed the work here. What if you are given a point that has an x-coordinate of 0, then that point is, the y-coordinate of that point is your y-intercept or the b value. So we could have just plugged in 0, but I wanted to show how you, in case this was something other than 0, 0, or in case you didn't get a point, you weren't given the y-intercept, what would you have to do? So if you were not given the y-intercept, you would have to temporarily substitute a point for y and x, put your 45 in place of m, and then solve for b. So the 45 times 0 would be 0, and then, which still gives me 0. Or if you didn't like using slope-intercept form and you wanted to use point-slope form, you could do that also. The point-slope form is y minus y1 equals m, and then in parentheses x minus x1. So y minus my y1 is 0 equals my slope 45 times x minus x1, which again is 0. And then you would have to distribute the 45 to the x and the constant over here, well that's just 0, and then y minus 0 is just y. So your answer would just be y equals 45x. Alright, so I did add an additional problem on the back because I noticed that there was a problem missing, or there's a problem similar to this on the test, and I wanted to make sure that we at least had covered it on the review. So okay, so this is the problem here that I wrote. It was one that I had from another test or worksheet somewhere else. So the graph here is showing a parabolic path of a grappling hook. So it's basically this hook that you're going to throw from one roof to another. So you're throwing it from the roof of one building to another building. Y is the height in feet, so these values represent the height in feet off of the ground. And then the horizontal x values are representing the horizontal distance between the buildings. The hook lands on the roof of the second building 50 feet away from the first building. So in this problem, you are not going to be given the vertex right away. You're going to have to actually find that using your equation. So that's why I made a note here that we didn't find this until after part A. So for right now, pretend that you don't know or don't see what the vertex is. And the only information that you know is your 0, 25 is this point. This point has coordinates 10, 40, and this coordinate has points, or this point has coordinates 50 and 40. And we're going to write an equation for the parabola. So we have a similar situation like we had in problem 13, I believe it was, where we're going to have to substitute the 0 for x, the 24 for y. So I worked those out down. I worked that out down here. So for part A, in order to write the equation, I used 0 for x, 25 for y, and to put it into my standard form. Substitute the 25 for y, the 0 for x, and then simplify, and I get 25 equals c. Then use the next point, 10, 40. You substitute the 40 for the y and the 10 for your x's. 10 squared is 100 times a is 100a, 10 times b is 10b, and then you can substitute the 25 for c, since you already found what the value of c was in the first part. But then move that 25 to the other side, so we have our like terms on the same side. So that's going to give us our second equation now, 15 equals 100a plus 10b. Then we're going to use the third point, the 50 and 40. 40 was our y coordinate, so we plug that in here. 50 is your x coordinate, plug it in there. Square the 50 and you get 2500a, and then 50 times b is 50b. Again, substitute the 25 for c. Subtract 25 to both sides to get your constants on the same side, and you get your equation 15 equals 2500a plus 50b. Now we're going to use these two equations. If you look at your coefficients for a and your coefficients for b, since b is smaller, I'm going to multiply this equation by -5 so that I can cancel the b values. So when I take the, actually I think I wrote it down here, yeah. So I took -5 times this equation and rewrote it up here. So -5 times 15 is -75, -5 times 100 is -500a, and then -5 times 10b would be -50b, which is what I wanted to cancel out those b's. Combine your a's and you get take your 2500 minus 500, you get 2000a. 15 minus 75 is a -60. Then divide by the 2000 and I get a equals -0.03. Once you've got that a value, then substitute it back into either equation 2 or equation 3. I chose equation 2 because, again, it was easier, it was right here. But you're not going to use the -5. You already had used that for this part here. So this is the equation that I'm using. So the 15 I bring down equals the 100 times a, which I'm replacing with -0.3, plus 10b. Multiply the 100 with the -0.3 together, and you get -5 plus 10b, and then add your 3 to both sides, divide by 10, and we end up getting our value of b is 1.8. So now that I've got my b, my a, and in my first step, my c, I can then write my equation. So that's what I have right here. So again, standard form is y equals ax squared plus bx plus c. But when you're writing your equation now, you want to put the y and the x's back in the equation. You're going to substitute the a value that you found, the -0.03 in place of a. Still is going to have an x squared, plus your b, which you found was 1.8, and then the c was 25. So this now is our equation of our parabola. So that's the equation of this parabola. So now the second part of this, I asked you to find and interpret the vertex of the parabola. This is where I'm finding the 30, 52. Well, let me show you how to find that, because you're not going to be given that information. But since we found our equation now in standard form, when you have an equation in standard form, you were given a formula, or you should know the formula, to find the x-coordinate of the vertex, which we call h. We use the formula h equals -b over 2a. So the -b, which is 1.8, divided by 2 times a, which is -0.03. So I multiplied the 2 together with the -0.03, and then I divided, and I actually got an h value of 30. So -1.8 divided by -0.036 is 30. Then in order to find the k value, you have to plug that 30, which is the x-coordinate of the vertex, in place of x in the equation. So that's what I did here. So k, which is the y-coordinate of the vertex, is going to equal the -0.03 times 30 squared plus 1.8 times 30 plus 25. And here I just plugged this in my calculator and let it do the work for me, and I got k equals 52. So my vertex now is 30, 52. So if I look back at the graph, that is the highest point on my graph. So that's the maximum height of the grappling hook was 52 feet when it was 30 feet away from the building. So that's one way you could describe it. I didn't mention the maximum value, but In my interpretation, I just said the hook is 52 feet high when it is 30 feet from the building, the first building. So I changed my wording a little bit a minute ago, but either way is fine. Okay, so now the reason why I wanted to do this problem in the first place was so that we could practice this part C, which is what is the average rate of change in height over the interval in which the hook is increasing, when the hook is decreasing, and then they want you to compare the average rates of change. So what you're basically finding is the slope between, use a different color here, so you're finding the slope between this point here and this point here. So the slope between those 2 points is basically what we call the average rate of change when the graph is increasing. So we're going to use the slope formula. So I wrote it down here. So you're increasing, the graph is increasing from 0.25 to the point 30.52, which is your vertex. So we needed that vertex in order to answer this question. Then take your slope formula, y2 minus y1 over x2 minus x1. I get 27 divided by 30, which is 0.9 or 9/10. Then I do the same thing with the decreasing. So if I look back at my graph, it's decreasing from this point to this point, but you're finding the slope or the linear change between these 2 points. So using the slope formula again, I use the point, so the graph is decreasing from the points 30.52 to the point 50.40. Subtract your y2 minus y1 over x2 minus x1, and you would get a negative 0.6. So that's the rate of change when it's decreasing. This is the rate of change when it's increasing. Now when you compare them, you don't really want to don't take into consideration the negative. It's basically a line, so you want to state which one is steeper. So when you are talking about rates of change, it's steeper whenever the absolute value of these numbers is greater. So if we disregard the negative for this one here, 0.9 is bigger than 0.6. So the average rate of change when the hook is increasing, that 0.9, that rate of change is greater than the average rate of change when the hook is decreasing, because that was the 0.6. All right, so hopefully that was a good review for you. Please study and practice doing these problems on your own. Good luck.